Hello, I'm Gary and welcome to the session for Angular 2. I welcome you for the session on behalf of Edureka. And in this session, we'll be talking about a very basic demo of how you can get started with Angular 2, what is the concepts of Angular and how you can actually work across with Angular to create a single page application for a client application. And to introduce Angular, there are a lot of things that I would want to explain, and some of the things I would want to touch upon is the evolution, how AngularJS was created, and what are the different features of Angular, and what is the actual architecture of Angular that we are going to work upon in case of Angular 2. So let's quickly get started with this particular session. I will be open for questions during the session, but in case I believe that it is something that will get answered during the presentation, I'll keep that particular question on hold. So very good morning to the session, and let's quickly look at what is web development in the first place. So when you are creating a web application, there are a lot of challenges that come across with a traditional approach. A normal HTML page comes with a method of architecture where whenever there is a user action, it makes a request to the server and there is a response to you. During this particular response, it actually changes the page from one particular page to another. So there is a lot of processing that is actually happening. And the processing actually happens on the DOM, which is there in the browser. What is DOM? We'll actually look at that in some time. But remember, whenever you are making a request, there is a load on the server. The server is processing something, creating an HTML page, which is actually the DOM that gets printed out on the browser session. So whenever we talk about an web application and there is a response that comes from your server, you would have an HTML page which will have a structure, and that particular structure is very unique. This particular structure has a head and a title which would provide the metadata of that particular HTML page, and you would have the body and the other content of the HTML page. So whenever there is a response, the response actually comes in an HTML format, which is a hypertext markup language, which the browser understands to make changes to the DOM. This is the one that provides the visual communication to the client or to the user. And this is where your whole structure of your application comes into picture, and you would be able to manipulate the DOM with JavaScript. If you look at a very simple document object model or a very simple structure of the DOM, you would notice that it is a very structured environment. The structured environment is basically divided in such a way that everything is an element. Whether it's XML, whether it's XHTML, whether it's HTML, you would have all created with your elements. And the hierarchy comes with a document. The document is basically an object which will go ahead and get the elements arranged in a fashion that is understandable, with the head taking the metadata of the HTML, with the body taking the content of that particular client view representation. Each node is basically an object representing a part of the documentation. That's exactly what DOM is. I have a quick question coming in which says, so the DOM architecture is divided as per hierarchy. Yes, absolutely. The DOM architecture is actually divided as a hierarchy of elements, and you can actually call that as an element, or you can call that as a component. Whatever the case, you have some particular structure that gives the metadata of the HTML, some particular structure that provides you with the content of the view. So again, what happens in a traditional approach? You have the DOM, which is provided in the browser. That DOM is provided from the server after a lot of processing. The server processes static HTML pages, static CSS, JavaScript pages, and as well as you would have some kind of processing or some kind of processing language, that processing logic that happens in the server. And this is the one that creates the DOM, and whenever there is a user action to change any kind of data, you actually go to the server with a request, the server identifies what is the request, processes it, and then serves back your processed HTML and other static files. Whenever there is a static file, remember there is a request and response, which means there is some amount of load. And during that particular scenario, if you have a single page application or if you have a structured environment, your load on the server might reduce. And that's exactly what Angular 1 or Angular 2 or any other single page applications target. Initially, when the web started, it was pure JavaScript scripting. And JavaScript was originally created as a scripting language. It was a very simple language that used to go ahead and do some changes to the DOM, some action, and that is what it was restricted to. But later it started evolving, and it also started allowing something called as XHR request that can happen from the browser to your server. And in this particular scenario, there was some idea that came across with a lot of people, and there was a library called as jQuery that came into picture. When jQuery came into picture, it helped you create AJAX calls, DOM manipulation pretty well. What jQuery basically does is it basically wraps your complex code, whether it's a DOM or whether it's the code, and it basically helps you manipulate the DOM in such a way that you would have some particular action which is repetitive. They were put into a particular function and the action was being done. So it helped you create lesser amount of code with respect to JavaScript. What are the benefits of jQuery over JavaScript? The benefits of jQuery over JavaScript is that it provides you a lot of reusable functions that can be reused for making a DOM manipulation or for creating your own functions that are helpful. So that is exactly what jQuery did. But there was a very simple problem with that. The simple problem was actually a very big problem. It did not have a structure or did not tell how to architect that particular application. So it did not provide you how to architect a very simple client-side application because developer had a lot of flexibility with JavaScript. And this created a lot of confusion when there was a big project and a lot of people were working in a particular project, which created a lot of issues with the application. Parallel development was an issue, unit testing was an issue, it did not have a real structure. It really was difficult to maintain later on. And in case of client-side application, there was no real structure, and that made it very difficult for maintenance because every developer has a different skill, and it's something that was becoming a problem in a lot of big organizations where the teams were bigger. For these situations, you actually require a framework, and that's exactly where Angular and a lot of other frameworks started coming in. Since jQuery did not provide a real structure, it was basically a library providing you freedom to go ahead and manipulate the DOM. It helped you associate the changes in the DOM with very simple code, but the problem was it did not have any kind of structure. That's kind of very important. So what is Angular? Well, Angular is basically a single page application framework, which is something that is very unique to single page applications, and it provides you with functions, libraries, as well as an architecture to create an application, as well as some kind of functionalities that provide support to that particular architecture. And it was actually created by Misko and Adam. Misko and Adam were basically the one who created AngularJS. It was then taken over by Google, and it's actually maintained by Google right now. This was Angular 1.x scenario. And it really picked up after 2014, and Angular 1 was making news with a lot of applications created with Angular. Angular is basically a client-side application, and it's used to create or develop a dynamic web application. It helps developer create single page application, and it provided a lot of best practices for web development. Some of the best practices were trying to avoid sending static pages, trying to avoid creating a scenario where there is a lot of processing on the server, unnecessary processing on the server, and any kind of situation where you do not have testability or maintainability was taken into account when creating this particular framework. And this was something that was really important. And AngularJS not only helped manipulating the DOM, but it also provided some particular functionalities that created modular structure and some particular functionality that created any kind of manipulation, that managed manipulation for the DOM, and they were actually called as directives and components. So 1.x made a big leap from jQuery to a framework application, and that really helped a lot. But there were some basic small issues with that particular scenario. And the scenario was that Angular 1.x, though, was very good in managing a single page application where every section of the component was isolated or scoped section. Like say, for example, if you have a page with a navigation bar, a sidebar, courses, everything was separated pretty well. And they had their own architecture, they had their own design of MVC, MVM, MVVP, or so on and so forth. And in this particular scenario, it really had situations where you could manage every section of the application as a isolated or independent section. But it really had some problems with the dependency injection and some particular kind of scoping that made the change detection. The whole page in a single page application, like I said, is not reloaded every time. It actually loads the whole application in a go, and if there is any kind of data change or if there is any kind of update that is required to the server, that was actually done by REST APIs or any kind of XML based APIs, and that really changed a lot of scenario. And because static files were not processed again and again, and the page was not going to the server for change of URLs, it really made it a lot more easier to manage a single page application. But again, like I said, there were some very simple problems with change of scope, change detection, and managing scope or dependency injection. So that created some amount of understanding within the community to go ahead, upgrade it to a better scenario. A lot of organizations like JetBlue, Vivo, DoubleClick from Google, Freelancer, New York Times, PayPal use these frameworks for their own application development. Angular 2 was targeted very specifically at the problems of Angular 1.x and to make 1.x like framework a little more scalable, a little more better. And this was something that was very unique to Angular 2.0. Angular 2.0 said, okay, let's do away with a very single big chunk of a framework. Let's divide our framework in such a way that all the concerns of the framework is divided into different modules, and you would be able to reuse that particular module even if you are not using Angular 2. And that's something that was very interesting. And that's where the Angular 2 goal actually started. It helped a lot of mobile development, and it also went ahead and helped desktop development in that particular scenario, where modularity was the basic core thing that was actually used. And when you have core functionality which was modular and which was lighter, it made the application a lot more faster. It did not just change it into a modular function, a modular library or a modular framework. It also changed the way in which the change detection was working, or it also changed the way in which scoping was done in an Angular application. So that really was very unique and very nice. And Angular 2 uses something called as ES6, or it uses TypeScript for Angular development. In TypeScript, one of the basic difference between TypeScript and JavaScript is that TypeScript basically provides a lot of static typings which help scalable application development, and these types are kind of a little unique for backend development before, but now also is available in front-end development. TypeScript invented or discovered or innovated, rather I would say it innovated with a static typing, because JavaScript is not statically typed, which was basically a problem with JavaScript. And since it's a dynamically typed, runtime typed application, there were issues when you really wanted to have some amount of type there. So it really made sense to have some amount of typing in very important sections of the code. And this was really important for application development, which is kind of scalable. ES6 also innovated a lot of features into its own JavaScript, and the iterators, Python style generators, reflection APIs for off loops were actually introduced to ES6. classes might get introduced with ES7 as well, so that will create a lot of changes there. So what are the building blocks of Angular 2? There is a question asking how directives helped in manipulation. Well, directives basically were a chunk of code definitions that was associated to the DOM, which made changes to the DOM with a reusable code. And this reusable code was really beneficial whenever you are making changes to the DOM. And that was very important when a single page application like AngularJS came into picture, because it was able to go ahead, find these directives or attributes in that particular section, and it was able to make the change according to that particular definition or identification. So what are the main building blocks of Angular 2? Well, it was basically components, and it was revolving around components and component interaction, which means that Angular says, let's go ahead and use web components to create custom components which have their own functionality. What are components? Something like dev, span, they're all simple components, and that's something that was very unique to web development some time back. But now almost all of the frameworks, or most of the frameworks, have their own method of creating components, or they revolve around creating components, because it becomes a lot reusable and a lot more beneficial when targeting any kind of scalable application. So Angular said, let's use this particular innovation, or let's use this new feature to create your own components, allow your application to create your own reusable component, and help you create your own component in such a way that your component encapsulates some particular functionality. And that particular functionality would be defined by either metadata, which would associate it to a DOM template, and that particular association with the JavaScript actually happened with something called as data binding. And this was really very good when components came into picture, and this actually helped create a lot of changes, because components have the capability of being isolated using something called a shadow DOM. If you want to have a look at what is shadow DOM, please have a look at Mozilla documentation for JavaScript, and shadow DOM is kind of quite explained in terms of how it encapsulates styles, functionalities, as well as the DOM element. So the whole idea of Angular 2 was Angular components, and Angular components use something called as dependency injection and services to create functionalities. In case of DOM manipulation, it used directives and templates to provide the view and make changes to the DOM, and that was very good. Taking all these into consideration, when you combine all of these, you can take all of these into one single chunk of application, and you would have an application that can be divided into features, and these features can actually go ahead, be put into a particular Angular module, and these Angular modules would be good. And this particular Angular module would be isolated and they can be reused. So that's something that was always there with Angular 1.x, but it made it really good in Angular 2.x. Okay, great. So in case of modules, it's a very simple Angular module. And Angular module is defined with an annotation that's provided with decorators called as decorators like ng module. And ng module helps you create an Angular application which encapsulates a set of features into your Angular application, and you can actually divide your concerns and divide your features, which is a lot maintainable. You can just plug in and plug out those features without impacting any other application. And like I said, each Angular module can have its own components, directives, and services. And in case of any kind of views, you have your own templates which are associated with components, and that is manipulated with directives and pipes. So that's something that was there with Angular 2, and it tried to maintain that. So what are components? Components are basically encapsulated functionality, templates, data, which is bound with something called as metadata of components, and you can use a component to create your own metadata. So that was something that was really the core idea of components, and the core idea of components was created in such a way that you would have a root component, and that root component will have its own component tree, and the root component will work in such a way that it would define other custom components or HTML components, and you would definitely have that particular structure created like it would be there in the DOM. That was something that they tried to maintain, and that is something they actually tried to use that. And like we looked at before, you can actually create components of navigation bar, you can create components of sidebar, you can create components of courses, and this was something that was very unique to a lot of frameworks, and it actually helped creating the application in such a way that these components can be reused. And this reusability came from minute, smaller chunk of components. Say, for example, if you have a lot of courses, you can actually create a component which is courses, and you would have smaller components which are course 1, course 2, course 3, and so on and so forth. And still you would be able to reuse that particular course component to create a lot more components whenever required. And how do you create a component? Well, you create a component with component metadata, and it is created as a component tree. So you would have a root component which would have its own child components, whether custom or HTML tags. Great. So how is component actually created? Component is actually created with @component annotation with metadata that associates template as well as component classes. And the metadata defines how the component is going to be created. Metadata defines how the change detection works. Metadata defines how it is going to bind any kind of data from the component class to the template. It also defines how data is passed from the template to your components with something called as events, which can be associated or which can be used to create an association for your JavaScript classes and templates. So what are the building blocks of the templates? Well, the building blocks of the templates is basically a very simple view or a very simple DOM. You can define a component view with its companion template, and the template is the one that defines another custom template or another custom or defined HTML element, and they can be used and reused again and again. And whenever you have your own custom elements, you would basically have your definition of the view defined there. And that is something that is very unique in case of Angular 2, where the association of components and templates are done with property binding as well as event binding. So any kind of data change from the JavaScript classes to the template is done with property binding, HTML properties or attributes that we call, and expressions. And in case of any kind of user action that updates or any kind of action from the client, it is done with events, where events are used to pass data or events are used to trigger some particular functionality and do something extra there. And I have a quick question from Andrew, who is asking, how do we define metadata and how are modules and components related? Well, as I explained, components are basically units of Angular 2 application, and Angular 2 application are created as components, and each of those components are mixed to create a particular functionality, which is a chunk of functionality which creates a module. So you basically have a module with a lot of components, and these components are either reusable components or independent isolated components. So that's something that was the core idea. And the dependency injection process is something where you resolve some particular dependency and inject it into the component class. This is something very similar to what you have in the backend application. And you would be able to go ahead, create your own dependencies and use that using the dependency injection to inject it into your JavaScript component. It provides you with new features within the components and method to go ahead, share some particular data, or method to go ahead, reuse some particular functionality and work with a particular scenario where you would be able to inject some particular data or reuse some particular data, inject some particular functionalities or reuse some particular functionalities into your component class. And this particular component class would be able to work with that, and that helped because components are isolated. That helped with creating a very simple shared structure within the application module. So what are services and how do dependency injections actually work? Well, a very simple way of defining dependency injection is it is a process where dependencies are created if it's not there and resolved if it is there and pushed into your dependent objects. So if a component class is dependent on a particular service or a directive is dependent on a particular service, you would be able to inject it using the dependency injection process. And the dependency injection process will resolve the dependency or create the dependency and resolve it and push it into the component class. The data access feature, the logging feature, business logic feature, configuration features are something that can be put in services. And you will be able to fetch data from the server also because you have that particular configuration business logic there. So what are the building blocks of any kind of data manipulation? Well, the building blocks of any kind of data manipulation are basically directives. You would be able to manipulate your view data or manage the data in the view using attributes or classes or some particular functionality which are provided with the directives, which are either created as attributes or classes. So that's basically what directives are. You create a particular set of functionalities which is detected based on whether a particular class is there or not, whether a particular attribute is there or not, or whether a particular component is there or not. You can also create your own custom directives if there are some particular directives which are missing in your Angular application. Great. So let's quickly look at the architecture. All right, great. So whenever we have a requirement of creating an Angular application, there is a particular structure that you might need to follow. The first structure that you might really want to follow is some quick start that is provided by Angular, but using a quick start really needs some particular tools to be installed. The first thing that you might want to do is go to docs, go to quick start, and then download the quick start seed. When you download the quick start seed, it has a particular structure with all the definitions, all the configurations that are needed for Angular application development. It has a lot of tools which are dependents for development. It has a lot of tools which are required for production, and that is defined in package.json. In package.json, it defines all the dependencies that are required for production and all the dependencies that are required for development. Any dependency that is required for development is development dependency, and any dependency required for dependencies in production is dependency. So that's something that is there. And what is package.json? Well, package.json is provided by a package manager called as Node Package Manager, which is something that you'll get by installing Node. So the tool that is required for Angular 2 development is Node.js, where if you install Node.js, the basic tooling as well as the basic package manager or the package management tool will be available to you. When you go to this particular site, nodejs.org, you would have your own binary or your own executable that your operating system supports will be provided to you. You can download that, or you can go to the download section to download a binary which is not for the desktop or that particular hardware that is installed there. And after you download, there are two commands that are going to be available to you. One is node. When you do node v, it will give you the version of node. When you do npm v, it will give you the version of the node package manager, which is a package manager for Node.js. npm uses package.json to manage its dependencies. If you notice in the quick start that I have downloaded and extracted, and if you notice, there are some scripts which you can use in the command line to run. There are dependencies, and there are dev dependencies. Dev dependencies is something that is required for development. Dependencies is something that is required for production. And you have your own Angular framework dependencies that are defined well in advance with their own version numbers, and they can actually be used to install your application. So how do you use your Node.js to install your application? Well, your dependencies can be installed with a particular command called as npm install package -- save, and this will create an entry in package.json. Package.json will be there in the root of your application. And whenever you have a development dependency that you need to install as well as provide as an entry to package.json, use --save dev. And when you have an application which has already created a package.json, has all the dependencies, just go ahead, click npm install, and this should install all the packages into a folder called as node package, node modules, which is there in demo session 2, say for example in this particular case. And if you notice, I have actually done npm install. It has installed this particular node modules folder, and it actually uses this particular node modules folder to keep track of your dependencies as well as your development dependencies. And Angular has its own folder which uses that to keep the packages there. Once you have gone ahead and created this particular node modules folder, you are actually ready to use the application, because the quick start actually gives you a very basic templating that allows you to bootstrap your application and get started with the application very soon. So that's kind of a little advantage for your application and application development, and you really don't have to worry about managing your versions, managing your dependencies, development dependency versions, and so on and so forth. So that is something that Angular definitely does well. I have gone ahead and installed an application here, application dependencies here, and I'm using this application dependencies section. So let's quickly go back and look at what is the architecture of the quick start and what is the architecture of the application. Like I said, modules are basically a chunk of features or chunk of reusable features that are put into an isolated section so that it can be reused or it can be kept isolated. A module can have components, services, values, or reusable functions, and these will be very specific for the module where it is defined. But also remember that you don't need to really keep your modules with all the things. You can keep just a module which has components, a module which has just services, just functions or values for that matter. And your application would look something like this. You have a root component which will define the view, and that particular definition is created with something called as an component annotation. And the component annotation class is one that provides you all the functionalities. The component annotation class is bound to the template, which is basically the DOM structure like we just discussed. And this particular DOM structure is associated to the component class using something called as metadata. Metadata is the one that provides how a particular component is created, what is the component, and what is the functionality associated. Any kind of changes to the data, any kind of change detection that happens during the change detection process, or any kind of data manipulation from the JavaScript to the template is managed with property or attribute binding using expressions, and any kind of data from the template to the component class is done with event binding, which is basically user actions in end of the day. And in case of any kind of DOM manipulation, the DOM manipulation can be done using something called as directives. Directives are something similar to components. The only difference between directives and components is that directives would not have a template. And it is kind of very important to understand that directives are just set of functionalities that do some particular job, does not really provide the view. If you really need to have a view in your application, that comes with your template, and that particular template is actually associated with components. So if you need a view, use components. And if you need some particular presentation logic, if you need to keep some particular data because components are isolated, you can use services or injectables for that. So what are the Angular Quick Start program components? Let's quickly look at that in some detail. So package.json is the one that provides Angular dependencies, whether it's needed for production or for development. And Angular provides little amount of support to bootstrap the application structure for you, where you will be able to manage the application structure pretty well. The second thing that is going to be there is after you do an npm install. When you use the command npm install, it installs all the dependencies and install the node modules in that particular folder. And it's kind of really nice to know that all your dependencies are in your node modules folder, and in case you need to manage that, you can manage that from package.json directly. So if you have a package.json and the application structure and no node modules folder, you can actually copy that chunk of files and send it to somebody else who can go ahead, unzip it, install all the packages because it's defined in package.json, and that particular person's development environment will be set up. That's really something nice about package.json, node modules, and npm package manager. Let's quickly look at what are the other sections that are available. Angular Kickstart provides a TypeScript method, a TypeScript mode of development, and since you are using TypeScript, you have to compile your code to JavaScript. TypeScript is, like I said, is nothing but JavaScript with types, and you should be able to compile your TypeScript to JavaScript. One of the major differences, or one of the major reasons why TypeScript is used, because it provides static typing and some particular features that are not going to be available in JavaScript. And then I really recommend that in this particular scenario, it really helps a lot sometimes to have static typing. Any kind of compilation is done with a TypeScript compiler. You can install the TypeScript compiler using the TypeScript using the command npm install -g TypeScript. This -g is kind of unique because the moment you specify -g, it will be installed globally for your system, which means that you can use TypeScript for any of the projects, and it is not restricted to just the project you're working with. It provides some amount of basic static typing and some amount of application development features like interfaces, classes, decorators, and other set of features like generics, which really help application development pretty well. And that's really nice about that particular thing. Any kind of compilation requires some particular configuration to tell how the compiler is going to detect TS files and what it is going to build and how it is going to build. That is provided in tsconfig.json. So let's quickly look at what tsconfig.json defines. It defines the target of what is the JavaScript version that you need to install. It also defines the modularity of your node application, whether it's CommonJS or system, which provide modularity to each of your files. Generally, JavaScript files are not modular, but CommonJS or require.js and system.js actually help you create modularity for each of the files, which means that if you create main.ts, which is a TypeScript file, that will be a single unit of module by itself. And the second modularity is provided by ng module, which is the Angular application. So I will not be wrong if I say that Angular modules encompass a lot of file modules which are using CommonJS or system.js as the file modularity. So difference between Angular modules is that it's a chunk of file modules, and the file modules are done with CommonJS or system.js. Mode resolution is something that is defined with Node, and that is something that is a definition of what is the runtime. And if you define source map as true, the compilation process will also create a .map file. A .map file is helpful when you're debugging your JavaScript application. Decorators helps you with the decorators in TypeScript. Libraries are the one that this particular compilation supports. ES 2015 is the one, and DOM is the one that is being used for your application compilation. There are two things that come very specifically related to types, and that is no implicit any and suppress implicit any errors. Let's quickly look at that in a moment's time, but let's go ahead and see other sections that are available. I'll come to this particular tsconfig in some time. There is also a file called systemjs.config.js, and systemjs.config.js provides you the mapping for what files are going to be included in index.html. Index.html is going to be the only main HTML file that is going to be served by the server. And this particular HTML file is going to be served only once, and that's about it. Everything else will be either JavaScript or JavaScript HTML templates. It has a set of JavaScript which is induced in script tags, and some of them are Zone.js, System.js, and polyfills for your browsers, and systemjs.config.js. What systemjs.config.js does is it maps all the dependencies in one particular section and uses that map to import whenever there is a requirement. The first pathing is npm, which resolves to node modules. We already have node modules folder here, and the path that is mapped is angular/core/bundles/core.umd.js, and this maps to node modules, Angular, core, bundles, core.bundle.js. This is what it maps to. And the second mapping is for the application, which is the app folder. So our app folder is the one that is going to have the application. We'll create that particular app folder at this particular point of time. And there is also some other dependencies like in-memory web API as well as RxJS. RxJS is actually Rx observables, where you would be able to work across with asynchronous JavaScript programming with this particular library. And our package is actually the app package, which has a default extension of JS. You can also have a default extension of TS and provide a TS compiler in your HTML page and work across with that, but I do not recommend that. Try and use default extension as JS, which eases or helps faster loading of your application. Well, I also have a question coming in about what are observables. Well, we will try and look at observables in a moment's time. We get into that particular flow of the demo session. And once you have mapped, if you notice, it has been imported, and after that you import main.js file. So your main.js file is actually going to be imported from your application app, and your application app slash main.js is going to be the path, because app is mapped to your app folder. That's what it is going to be mapped. So what technically is happening in your index.html is it imports the dependencies, it imports systemjs.config.js, and it imports the app from app/main.js. We don't have main.ts here. We really are actually compiling our main.ts file into a main.js file. Great, so this is our index.html and our dependencies for our application. Let's quickly go ahead and create our application here. Let's do one thing. Let's go ahead and create two files, app.component.ts, which is going to be our component definition. The second file is going to be app.module.ts, which is going to be modular. And the third file is going to be main.ts, which is going to be our main import of your module. What all do these files do? App.component is going to be the definition of the root component or the root component tree, because remember we discussed that each of the root component can define custom components or can define HTML components inside it. It basically creates a DOM structure, which is a tree, like an object model tree, and that is exactly what your component is going to have. And this particular root component is one that we are going to bootstrap. But before bootstrapping, let's go ahead and also create an Angular module that is going to have your root application. And the root application is basically what your component, and your module is the one that is going to be imported and bootstrapped. You are going to bootstrap your module in main.ts, and main.ts is the one that is going to be imported in HTML file as system import main.js file here. Great. So let's quickly look at some of the features that TypeScript provides. TypeScript provides static typing. That's one of the main use cases for TypeScript. Okay, great. So I have defined a variable and I've assigned the type string. String is a basic data type in JavaScript. Other data types that are available with JavaScript is number, boolean, and the last thing is you also have types objects in JavaScript. But you really do not have a type in TypeScript to create that. So in that particular scenario, you can use something called as any. Any would refer to something that is an object, whether it's an array, whether it's a function, whether it's a class, anything. So anything apart from string, number, boolean can be defined as an any. You would also be able to go ahead, define an array by creating an array square bracket. This would define an array which can have any type of object within it. So one can be a string, one can be a number, one can be a boolean. But if you define a boolean array here, you would only have an array with booleans. And if it's not a boolean, it will start throwing errors because it's statically typed. In case of number array, you can have a number array. In case of a string, you can have a string, and so on and so forth. So this is the basic static typing that is available with TypeScript, and you should be able to work across with this pretty well. The other things that are available with TypeScript is interfaces. The next thing that is available with TypeScript at this point of time are classes. You can also have enumerators. You can also have some other generics. You can also have extension of your classes and implementation of your interfaces. So you can implement the interface on a class, you can extend your class to have inheritance from class to class, and you can also define enums and types with TypeScript. So this is very basic about TypeScript. In case you want to have look at TypeScript in a lot more detail, try out the handbook. It's pretty well written. I find this particular documentation quite good for somebody who is a beginner to start with. And let's quickly go back and start creating our application here. So what is the goal that we are working with? The goal that we are working with is my app. But what is the reason why we are creating my app here? A lot of us have actually done application development like this. And whenever you create a very big application, you would definitely have looked at some particular application which defines HTML like this. And this is something which is not really maintainable. Angular said, or a lot of application frameworks say, why not go ahead and create components which are more readable and create an application that will have components which will have their own functionalities, and create HTML structure or a component structure which is more readable, will have their own functionalities which can be reused. So maybe you might have an email display that provides email tag, and you can have email header, and you can have email content, you can have email footer, and in case of headers you can also have email to, email CC, email BCC. This is more readable. This is more manageable as well. And whenever you want to make a change to the implementation, you can actually change the implementation of maybe email 2. You can change the implementation of email header independently, and that is kind of a lot more better, a lot more manageable, a lot more testable, because these are independent sections that does not impact the whole structure of the application. You can just go ahead, make a change to a particular header, and you can work across with that particular header as an independent structure. And you can also go ahead and make a change to email content without impacting or without making any change to your whole application. That's something really nice. Your implementation details might change, but your application really remains the same. So your application doesn't really bother about whether the implementation is for a particular X server or a particular Y server or a particular Z server. It just understands that it's an implementation that gets the data from the server. Your implementation details within that particular XHR request can be anything. So that is kind of something very nice. And because it's really independent and isolated, you can actually test each of them pretty well, and it introduces a new era of testing where client-side applications are actually tested. One of the biggest problems of client-side application is it is actually done in a very bad way, and we all have been doing it. We all have done it in a bad way. It's just that it was never accepted until this particular point of time, and it was never accepted that even the client needs to be tested and client needs to be maintained. So that's something nice that has happened over a period of time, and that's how the web has evolved here. Great. So that being said, let's quickly go ahead and create my app that we started with. My app is a component, which is the goal that we are working with. And ES6 System.js or CommonJS provides you with modularity within each of the files. The modularity is such that if you need a particular object, you would actually have to import it. And if you need a particular object to be used by some other file, you can export it. So which means that I have to import a particular object to use that particular object inside, and I have to export that particular object to export some other object if it needs to be used by some other file. So if I need to reuse app.component or reuse the component or use the component in any other file, I need to export it. So let's quickly go ahead and create a very basic definition of a component. Let's quickly look at what are needed for a particular component, and I'm going to go ahead and use something called as Angular Core, which is the core module or bundle of Angular application, which has a set of features. Your Angular application, your Angular framework will basically have a lot of bundles. Your bundles are a group of barrels. Your barrels are a group of libraries or functions that you want to use. So I would not be wrong in saying that Angular is modular. Angular will have a lot of bundles. Each of the bundle will have a lot of barrels, and each of the barrels will have their own functionalities. So I'm going to import an object from the barrel called as core, and I'm going to import export class app module. Basically, sorry, not app module. I'm going to export a class called as app component, because we are creating a component. But why is component imported? Well, that's because it's an annotation and we have to use that. Your functionality that's being exported is your class, and that's exactly what is going to be used by your module. But let's at least define our component with the metadata. Like I said, how are components created? It's created using the template as well as the class, and the metadata is the one that binds. So I'm going to push Angular metadata or the component metadata into the annotation called as @component. The first metadata or the simplest metadata that it can have is the selector, which is the name of the component that I'm going to use. So the name of the component that I'm going to use is my app, The second that I am going to use is template, because components can have templates. I'm using backticks. Backticks is present in your keyboard in the left hand side of one, and now we have a particular template that we can define within this particular section. I can provide multi-line templating out here. I can also go ahead and use very simple divs. You don't really need to go ahead create your own components ahead, but you can also do something like this. You can go ahead and create your email component in a different file called as email.component.ts, import that in your template, and you will actually start getting a component tree. Right now we don't have that particular requirement. We are just going to go ahead create a very simple template. I am going to create h1, and I'm going to go ahead say hello Edureka. This is something that is a template. So how is it bound to the class? It is actually bound in the template metadata. There are a lot of other metadatas available based on styles. If you need styling, isolated styling for the component, other features or other metadata like change detection, any other encapsulation, whether you want to have complete isolation or you want to have pseudo isolation, or you really don't want to have any kind of isolation. So those kind of metadatas are also available. Now that I have defined my component, let's quickly go ahead and define our module also here. I will go ahead define my module. I'm going to import from my core the annotation called as ng module. And the second thing I'm going to do is I'm going to define my module, and I'm going to export that particular module so that I can use that in my main.ts, because my main.ts is going to bootstrap my actual application here. So it's going to bootstrap your Angular module here. And I'm going to use some metadata here, and I'll explain what these are all about. Great. So what does imports have? Imports provide you the ability to import any other Angular module and use it within this particular module. So if you have a common module that is available, you can import that and use it within this particular app module. So it is going to be available across all the features which are exported in that particular module will be available across your Angular application. Second is exports, which is going to export your components as well as your modules. So if you are creating a common module which can be reused by a lot of people, you can export your components, you can export your modules in the export section, and those will be available for those third-party modules which will import them. So exports and imports are linked. Exports can export components as well as your modules. The third thing is declarations, where you have to declare all the components, directives, and pipes. This is a compulsory definition, and if you miss defining a component, it will not be available within your module. If you don't define a pipe or a directive, it will not be defined within that particular module. Bootstrap is something that takes the root element and bootstraps that particular element, or it takes the root component and bootstrap that particular component. And that is something very important. Without a particular bootstrap, your module will not bootstrap any kind of component. So if you have your root component, you would basically be able to use the root component to bootstrap, which will bootstrap other components indirectly because it's using the template section. And You have HTTP, which I'm going to import. These are some common modules that I'm importing that will be helpful for application development. And I'm also going to import the platform browser, which will help me import some particular common module. So the first module I'm going to import is browser module. The second module I'm going to import is common module, which will provide you a lot of common directives. Third is HTTP module, which will provide you the feature for HTTP request to the server. The fourth one is the forms module. Great. So let's go ahead and import our common module C. I don't have an export at this particular point of time, but I really need to define and declare my component here. So let's quickly go ahead and import my component or our component from app component, and let's declare it. Great. So we have declared, we have bootstrapped. Let's quickly go back to main.ts and let's bootstrap our application. Our bootstrap application is going to be a very simple just-in-time bootstrap that I'm going to use, where I will be importing platform browser dynamic, and I'm going to import platform browser dynamic function from there. The second thing I'm going to do is I'm going to import my app module, and now let's go ahead create bootstrap of the module, and I'm going to use the bootstrap of the app module here. So let's just bootstrap the module here, and I think we are ready with the application. Let's quickly go ahead and start the application. So I'm going to just go ahead and do an npm start, which will compile the TS files into JavaScript files, and it is going to start a server, a development server. It is going to keep watching for any kind of changes in the application environment, and it is also going to open up a browser tab to show that particular application. So this is our basic application that we can create with Angular. It's a very simple application. But what are other features that are provided with? Some of the other features that are provided with Angular is attribute binding as well as event binding. Event binding is done with round brackets. Attribute bindings is done with square brackets. Square brackets associate any kind of data, any kind of functions, any kind of variables or data from your JavaScript to your template. And you can have, say for example, selected developer, which is defined within your component and associated to a particular model value. Your model value will come from your JavaScript class, and this will directly take and associate it to your input tag. Let's go ahead and use something called as ng model, and I'm going to associate it to a variable called as model value, and I'm also going to go ahead and define the particular variable here. The other thing that I'm going to do is I'm going to say ng model options is standalone, so you can use the model as a standalone. And this, I'm going to say that it's going to be true. So the square brackets is basically going to bind some particular data, and the round bracket is going to bind the event which takes the change from your template to the JavaScript class. Let's quickly look at what is going to happen. The second thing that I'm going to do is I'm also going to create an expression which will bind the same model value or variable, and it's going to go ahead and print this particular test value there. Let's quickly go back and see what happens. So if you notice, the data of that particular variable is printed out in the input tag as well as the value. It is going to be one way, which means that model value is associated to template using property binding or expressions. The property binding is coming from the square bracket model value, and any kind of change is going to be triggered with a round bracket. Any kind of change is going to trigger an event, and that particular event is going to be captured in your JavaScript as well. So that provides a test mimicking it's actually one way, but I'm trying to mimic two way because I've used square brackets as well as round brackets. If you want to capture any other event, you can actually go ahead and do that with click, which will capture the click event. And I can actually create a function which says on click, which will go ahead and trigger that particular function. So whatever you do here will get triggered. That's going to be how your data is going to be defined. And let's see what it gets compiled to. So that's your two-way binding and your basic root application. But what happens when you have a lot of components? Maybe you might have 100 components, maybe you might have 200 components in a very big application. What happens there? It's better to manage your application files in a better way, because the moment you go ahead create a lot of files, it's going to create clutter in your application. So maybe I might really want to go ahead create a feature like maybe admin, and maybe create a feature like a user, and create a different folder called as components, a folder called as directives, a folder called as pipes, and a folder called as interfaces to hold all the interfaces, and maybe your home, also maybe login, maybe autocomplete, and There you go. You can have your components within that. You can create your directives. You can also create maybe a service here. Similarly, you can have your components here, your services directives. So each of these can be a different module by itself, and you can create your admin.module.ts. You can also create user.module.ts, and you can work across with that. So it should actually work pretty okay. So that this kind of folder structure or application structure would provide you a lot of flexibilities, and you can actually go ahead now, go to app.module, import that particular module here, and say for example if you create admin you can import your admin module and import it here. Great. Fantastic. So this is how you'll import your module, third-party modules or common modules, and you should still be able to work across with that. So that is how you would create a very basic single application, single page application, and work across with your application based on the scalability requirements, whether you want to use a very simple folder structure or maybe a complex folder structure. I invite you all for a training session which is going to have a lot more details in terms of interfaces, a lot more details of how injectables are created, how the dependency injection works, how you can create your own pipes and directives, what are the other features available which are inbuilt into Angular in case of directives and pipes, what are they, how you can define that, how you can define components and work across with multiple components, and how you can create multiple modules, test it, how to use different tools to work across with creating test beds and create unit tests for your application. These features for Angular 2 will be covered in our session, along with a basic introduction of Node.js, and we will also be doing a lot of codes, and we'll also be doing a lot of demos in that particular training. I welcome you all for the training, and I'm open for questions if you have any. All right, great. So I have a question here. What are observables? There is something called as XHR. All of you might have used something called as XHR, or you might also have used something called as Ajax in jQuery. What does it do? It basically triggers a request to the server to get some data, and then triggers a callback function that is triggered after a response data comes to your JavaScript. This kind of creating callbacks and this kind of async operation has been eased out in promises. Promises are basically promises that promise you that whenever a particular async operation is finished, it will trigger a callback function. And it can be triggered only at one particular place. But observables say that why not have the power of promises? Why not add the power of events? Why not make the observable in such a way that you can manipulate the observable as an array, and you can work across this particular observable over a period of time, or you can schedule it. So you can either schedule how the observable is going to be triggered, and you can capture that, or you can subscribe that, or you can listen to that at a lot of places, because it has the power of events and promises does not. But since they are basically promises which deliver a particular function trigger after a particular action has been done, you would be able to trigger a lot of functions from different places when the event occurs. So that's what basically observables are. If you want to have a look at observables, just type for RxJS and library and JS JavaScript. You should be able to find that particular URL. Let me quickly type that. JS and observable and RxJS. So this is the one that will provide. So it's basically a set of synchronous libraries which allow event-based programs and asynchronous libraries that provide event-based programs, and it can be manipulated as an array. So this is all about observables. You can have a look at it, and in case you have questions, you really want to have a look at this particular video, you can contact the support team, and the support team will provide you with the details of this particular presentation as well as the video, so that you are able to have a look at it. And quick look at what your application can do. I'll just, maybe you might have a Node.js server which are created, and the Node.js server works separately. You might have a set of components which have their own components within. Login will have their own component, register, libraries if you have your own CSS, your own fonts, your own JS, pipes, services, and so on and so forth. And this should actually work something like this. So I have used a lot of libraries here, and I can enable it, disable it, I can edit it. So if it is enabled, it will show all these. So a lot of things, and this is actually one single component. This is one single component. This particular user list is one single menu section, and you have a different section that comes here. So these are all based on components. Each of the section is a different component, and they have been associated into the view. So in our session with Angular 2, we'll be talking a lot about how to use multiple components. We'll also talk a lot of how to use components along with services and along with other interactions like routes and directives, and we'll have a complete picture on that. Great. Fantastic. Again, thank you very much. If you have any questions, I'm open for questions. Andrew, Longbottom, What's, Sandeep? All right, great. Fantastic. Thanks a lot. In case you want more details about the presentation or the session that we are going to cover, you can definitely contact sales@edureka.co. In case of this particular video or the presentation, you can contact support@edureka.co. And I hope to see you in one of the sessions there. Again, thank you very much. All have a nice day. Happy coding.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!